Calculus 1, Topic 6.2, Solids by rotation. I want to give an example and then we'll look at the properties from these examples. Let's say we had two equations. Y equals x squared and y equals the cube root of x. Okay. Y equals x squared. Let's put that in red. And we'll put y cube root of x in blue. Okay, and we'll only consider the section that's enclosed, that's between 0 and 1. So we're going to erase this portion, and erase this portion as well. Okay. And here we are at x equals 1. And here we are at y equals 1 at this center point right here. Okay. This creates 3 distinct regions. Call this area right here region 1, this area right here region 2, and this area right here region 3. Okay. Now let's suppose we were to rotate region 2, and we're going to rotate region 2 about the x-axis. So rotation here. So let's recreate region 2. Okay. So to rotate this about the x-axis, I'm going to create kind of a reflection from here to there. Okay. And I'm just kind of to create a reflection by putting a dash. So I'm going to spin this so that this ends up going this way and then comes back around. And so as I go through, I'm going to kind of create a solid. Now let's see if I can kind of create the illusion of rotation. Okay, so you can see this part going around. And then I'll connect these 2 points right here. I'll connect these 2 points right here. Okay. And these 2 points right there, I'll connect. Okay. Kind of gives the illusion of rotation. So we have this solid piece. Now, I'm going to look at this as a disc. As I spin around, I'm going to slice this so that we can see one of the slices. And this is what you'll see, kind of a disc with a hole in it. The volume of this disc is found by taking the width here, okay, and in this case it will be a delta x, and then we have to multiply by the outer minus the inner radius. Okay. And the area of a circle is pi radius squared. And so for the outer, this area is going to be, for the outer area, it's going to be pi. The radius will go from here to here. So that will be the outer function right here, this graph right here, which is the blue one, which is y2. And y2 will be squared. The inner will be made out of the area formula, which is pi r squared, and the inner is made out of the red one, and so its radius will be from the x-axis up here, so y1, and then squared the radius. So the difference between the two would be pi y squared 2 minus pi y squared 1. Okay, so that will give me the area of the circle. So to find the volume, we'll multiply the area of the circle times the width or the thickness of the circle. So the volume will equal the pi times y2 minus y1 squared. This is basically radius squared. Times the delta x here. And we want to sum all these. So we go from 0. Let's see. We're summing these from the bottom here to the top there. So that's from 0 to 1. I'm sorry. Our deltas, I'm sorry, over here. So from here to there. So it's from 0 to 1 there, all over x. So from 0 to 1, 0 to 1. And this is the radii being subtracted, squared, times pi, and then times the thickness of the disk, which is delta x. So in other words, what we have is the outer minus the inner. Times the thickness. Outer minus the inner minus the thickness. And this is an area, so this will include pi. Okay, if we want to express the volume, eventually we're going to solve for the value of the volume, but for now we're going to work on expressing what the volume would be. We're going to rotate A about the x-axis. Now here's the x-axis right here. The x-axis is actually y equals 0. So, area 1, we're going to rotate this about. So what we'll get is this look here. And that's going to be rotated. Here. Okay. So that's the kind of idea of our rotation there. I should dash this. Solid. Okay, so let's take that apart. My integral first. From here to here will be along the x-axis here. And I'll be going from 0 to 1, so this will be my limits of integration, 0 to 1. Okay. Next, I want to look at my radius. I have two. I have an outer radius right here, which is this part, and I have an inner radius, which is in this part right here. So, first, the distance of the outer radius right here remains a constant 1. From here to here. That's a constant 1. So pi, and the radius here, squared, minus the second radius. The second radius comes from this part right here, that's the red graph, which is y2. So 1 minus y2 in the square. So y2 is the length of the radius of the second piece. Then all of that will be times a delta x. So 0 to 1 pi 1 minus, this will be x squared squared and then dx. Okay, I'll further simplify and then leave this to be solved. The pi can come out here, leaving behind 1 minus x to the 4th dx. Rotate A2 about the x-axis. This is the x-axis, which is represented by y equals 0. Okay. A2 is this area right here. So we rotate that about the x-axis. It's going to appear there. And that's our rotation right there. Okay. Now, we want to slice from this spot all the way to this spot. So that's from 0 to 1. 0 to 1, that's our slices. And then furthermore, we're going to multiply by pi times the radius. And the radius of the outer, which is this function on top, which is the red, that's going to be x squared. Or should I say y1. So y1 squared minus the blue part, which is the part that's now below, or the inner part, which is the y2. And then delta x for the thickness of this shape. Okay, so let's solve this. We'll pull out the pi, 0 to 1, and y2 will be the cube root of x all squared minus y2. So that was y1. y1 should be x squared. And then dx. And then I'll simplify this. This becomes x to the 4. This is x to the 1/3 raised to the second power, which will be x to the 2/3 power, and then dx. And from here, we'll take the antiderivative and plug in 0 to 1.